Alright, in this video I'm going to touch upon few stuff related to Makefile. You can think of it, Makefile, as a granddaddy of automation. It's around for quite a long time and it's very popular, important, it's very indispensable. So Make is an utility which will help you to build your software according to your choice. So for that has to happen, you need to create a Makefile which have to have some sort of rules about the process which will build your software. Makefile is all about rules. You need to specify clearly how your software is going to be build or do other stuff. It not necessarily, I'm saying build, it could be, the build signifies a lot of things. It could provide you status, it could provide you so many other stuff. Makefile is one file in a project, or probably many makefiles in many subdirectories in a project, which I'll show you in a real life example. So basically it is a very important tool. Okay, so without further ado, let me get into my Emacs. I have extracted out from my notes, which I'll show you in a moment. But before that, so if I wanted to show you a Makefile, so a Makefile, as I said, having a bunch of rules which will govern the way you build your software. Okay, so for instance, I have a few C file in a directory and I have a Makefile to build all those combined and output and all this stuff, pretty ordinary stuff. Makefile can get very complicated, believe me or not. I'll show you how it will be looking in a real life scenario in a big project. But before that, let me start with a small thing. So the first thing, let me show you a Makefile I wrote yesterday evening, just to show you that how it could be done. And Make has its own lingo. That means it has got a syntactical stuff which you can put inside Makefile while building Makefile. Okay, so give you the first glimpse. Let me open so this is a Makefile I wrote yesterday evening. It's just a rudimentary one. So what I did, but before that, let me sip my coffee. The coffee should be good in the morning. So what I did, the first thing, I'm assuming I'm sitting inside the project directory. That's why this dot signifies that I am inside in that directory. Okay, so next, these are the variables. These are all you see. These are the variables. It could be anything to your choice. Okay, so now I want to include all the files which is having in this particular directory, which is where I'm sitting and writing this Makefile. This is a for each loop which signifies a variable d, and this is as you can see, it is call up the or evaluate the variable cdir, which is defined on the top. And then this is a syntactical representation. Wildcard is a function which call the directory we have assigned, and underneath all the, in that particular directory, underneath all the C file which is having a C extension. Am I clear? So let me clarify things. So you can see this is a typical Makefile syntax. Okay, you can write this kind of stuff inside a Makefile. For each is a loop, d is the assigned variable. Okay, then it evaluating the cdir, which you can see on the top, that I've assigned it to the present directory where I wrote this particular Makefile. Okay, and you can see wildcard is a functionality provided, and it takes an argument, and I'm assigning it to all the C file, all the file which is having a .c extension under that directory. Okay, basically the output getting stored in the C file. This is pretty ordinary stuff, right? Likewise, objects are the file. You can see again it's a Makefile where it thinks it pat sub st, which is a pattern substitute, and in a brief you can write the syntax like this. This is Makefile specific. Pat sub st means pattern substitution. What I'll do this percentage mean anything or like, which is having a .c extension, to .o anything with a .o extension from this directory which we have defined on the from these files which we gathered from the previous step. You're following, right? This C file come from this statement, this assignment. Okay, and this is a syntactical way to substitute the pattern from .c file to .o files. Okay, now the binary is a static variable. It could be anything, whatever the name of your binary you want to generate. Okay, so you can name your binary ahead of time if you know what you are doing. All is a catch-all. You can think it's probably it's doing the binary. It has a dependency on binary. Okay, so these are the targeted stuff, these are the dependent stuff. Okay, so likewise the binary is dependent on object files. Object files you can see gather from the top. See, we have gathered few stuff, the .o file in the objects variable, which is provided here as a dependent. The binary is built out of these object files. Okay, so here I'm simply calling GCC. These are Makefile specific lingo. So $@ means, so take the argument as an output. Okay, so that would be the output of what we assigned as binary. Okay, so $circumflex or caret, whatever you say, means these are all the prerequisite file. Without having that particular those file, you cannot make this binary. As simple as that. This $prefix, $circumflex or caret, whatever you say, it is about getting all the prerequisite file which will help you to build that binary. With that, it could be, you can run clang 2. I'm running GCC here, you could run clang 2. Doesn't matter what is the compiler is. Okay, now again, this is a on the left hand side, this is a dependency. .o, any file with the .o extension has to depend on any file with .c extension, because .o files are generated out of .c file, right? In other terms, object files are generated out of C files. Okay, so again I'm running the GCC with the output. okay, as the name, and this less than means take the first instance of the dependency of the prerequisite stuff, not all. This means take all the dollar caret means take all the prerequisite. Dollar less than means take the only first requisite. Okay. Now, so this is another rule just to clean. If I decided I'll get rid of all the object file it generates, which is a .o extension, and the binary piece, because it oftentimes require we generate something, we probably get an error, or we probably wanted to enhance or subtract something from the binary generation. So this rule is important to clean things up for you, so you can start afresh. So you can see the Makefile is all about rules and pattern matching. Okay, and this is probably not so simple. Okay, the Makefile could be written in much simpler version, because I am expecting whoever is watching this video have little bit of understanding about Makefile. That's what I very first thing I said in the start of the video, that you probably using it, knowing it unknowingly, out of reflection, out of convention, whatever the stuff. I'm just bringing it up for those people who are not aware of it, or probably doing stuff but not haven't given enough attention. So these are the stuff basically. It could be a lot of other thing you can provide in the Makefile. So if a Makefile consists of thousands of files or lot of dependency, this Makefile could get even more complicated. There are more facility, syntactical enhancement in the Makefile. You can run the shell command inside Makefile. Okay, so which I haven't shown you here because I don't want to clobber your head with too many information. Whatever I'm showing you is good enough for you to get up and going with it. Okay, so it could, there are several other way of defining this. There is no standard way, but the basic is that I'm stressing it again and again. Makefile is all driven by rule and pattern substitution. The more you know about it, the easier for you to build the software. Okay, so this is one instant. This is almost the very rudimentary stuff. Okay, so before I show you the real life example of a Makefile, let me clear out few things to you, okay, which I have extracted out of my notes. Here are the few things. These are the shorthand notation which is used inside Makefile. What you have seen on the right hand side, I have used 2 or 3. Okay, so it is clearly written here. I will probably give this enlisting in the description section below. So whenever you require, you can look into the description section and find this up. Okay, and copy and paste it to your note if you need to. $@ the target file name. Okay, so $* target file name without the file name extension. That means if something has stat.c, it will eliminate the .c extension from it and provide you the stat. $, the first prerequisite file, as I shown to you on the right hand side. You can see on a building from .o from .c, I've given the first prerequisite of the file name. Okay, so and $+, similar to $, but include duplicate file. Okay, so $? the name of all the prerequisite that are newer than the target, separated by spaces. Okay. $@ mute the command itself. Say if I come here and if I put @ just before it, okay, before the command, what if you run without the dollars, without the @ prepended to a command, the command will get printed on the console. It's great to know what is going on, but in a complicated Makefile, and you don't want it to clobber your console output with all the stuff which you already know, because while building that Makefile, you already aware of it, what you are going to build. Okay, this is for small thing or debugging purpose. So you put the @ just before the command, it will simply mute the command itself on the console. It will produce the result, but it will not show you what command it is running. Without the @ it will show you what command it is running. Okay, info $info. Then so before running any, you can write, so Makefile, the tab is very important. It messed up right now. I'm just showing you the things you can, if you write like this, and if you write like this, info, this will compile my project. And if you have this kind of line just before what you are doing, this line will print on the console before executing the command. That's why $info and then the message, as you can see on the left hand side buffer, it is useful to provide you the information what the Makefile is going to do. So it will give you kind of reminder that what is supposed to going to do what, and you could put it in other way to provide some sort of information, spit it out on the console for your reminder kind of thing while building the stuff. So these things are Makefile specific. Okay, so whatever you are seeing on the left hand side of the buffer, these things, what, as I said, I probably just take these few particular things and put it in the description section below, so you can copy and paste it to your note or refer back to it without going to the whole video. So it would be great if you go through the whole video. I doubt whoever people go through the entire video without skimming it. People are so impatient these days. I don't know why. Anyway, so this is the kind of stuff you can use inside your Makefile. Okay, so to give you a example of a real life example of a Makefile, okay, let me take two software. So I'll show you the Makefile. Control X, Control F, and if I okay, I'm opening a popular application called dmenu, which is come bundled with the Makefile. So if I press enter, so this is the Makefile of a dmenu. Okay, so you can see you can include other configuration file inside the Makefile like this. Okay, so as you saw, it declares two variables and it is expecting this file to be present in that directory, and You can see it assigned the object file like this, which is come out of .c file. Okay, what I've shown you. So these are the if you do all, it will take this dependency with it. Okay, so these targets are built with the dependent on this kind of stuff. As you can see, the at sign is prepended with the command, so it will not spit out on the console while building. Okay, this information are for internal reference, not required to be printed out or known to the person who is building, because it's publicly available software. These things are there for the convenience and for the internal working of Make. Okay, so the end user probably might not wanted to cover their head with this kind of information. That's why these are muted. Okay, so there is a target for .c.2 to build something like as you see. These are the first prerequisite which has to be met. There is a config.h file. So I can go through all the, you can understand, right? These are the targets on the left hand side. You can see my cursor is hovering. These are the targets. If you wanted to get these targets to be properly built or properly work, then you have to, on the right hand side of the column, these are the dependencies. You have to have these dependencies met up to get this target to be fulfilled. As simple as that. There are left hand side, there are right hand side. Okay, so the left hand side specifies the targeted one, and the right hand side is the dependent one, which build the left hand side target. Okay, so this is not so big Makefile. Okay, so it has got various target, how to install it, how to these are the very common section comes if any of the lots of open source software comes bundled with this kind of Makefile, which will allow you to run make and make install. When you run make install, make check, make test, those are all defined inside the Makefile, which is come bundled with that software. It has to have, if the software instruct you to do, it's a very common thing. We generally, what we do, 3-step: configure, make install, in general sense, right? So the make and make install file use this particular Makefile. There has to be a Makefile in that project directory, which will assist or feed the make binary or make tool to look up and do the stuff, whatever the pattern, substitution, or the rules. These are all rules. These are all rules which will allow you to build your software according to your need. This is written by the people who released tmenu. I'm just giving you an example how things look like in a real life. Okay, so I could say, for instance, if I go to a Linux kernel source tree, there are several subsystems, and each and every subsystem has their own Makefile. That means if you change one subsystem file, you do not have to compile the whole kernel. You can specifically target it to that particular Makefile to get compiled. But to get the overall effect, you have to compile the entire kernel to be get bounded by the changes you made to a subsystem, right? So a project which is having a different subdirectory could have their own Makefile in those subdirectories. It not necessarily that one project have only one Makefile. It could have several Makefile in the subdirectories if it has or have one. Okay, So Linux kernel is one of the software which is having n number of Makefile, probably 500 Makefiles, the kind of subsystem we have in the kernel. And you can individually compile each and every Makefile. So you don't have to compile the entire kernel. If you change on specific subsystem, you can compile the specific subsystem with their Makefile. So what you are seeing here, this is a Makefile provided by a popular software called dmenu. As I said, most of the software come bundled with it. Okay, so if the author of the software not decided to do something else, specifically something written in C, C++, something, Perl's come with his own Makefile, which is makefile.pl. If you have ever used Perl software, if you get it and enter it, and you'll see there should be a file makefile.pl, which is a Perl Makefile. That's a Perl way of building stuff, which is written in Perl. Likewise, this is dmenu is written in C. This is a C Makefile. Okay, so likewise there will be but the point I am making this video just to make you aware, the Makefile is a place where you put your rules and pattern substitution to get the job done automatically. As I said at the very beginning of the video, Makefile is a granddaddy of automation. Okay, so it helps immensely if you deal with a large project file with thousands of files scattered all over the place in a project directory. It will help and save you to do a lot of stuff by hand. You have to, but there is a caveat here. Makefile get very complicated if you haven't put care behind it. So whatever you put in your Makefile, make sure you make it very explicit and very clear thought about it, because if you do airy-fairy stuff, it will incur the compiling time, it will incur the build time. Okay, so Makefile has to be fine-tuned in such a fashion that it should not gobbles up too much of resources too. That's why the shorthand exists. That's why you need to spend time to think about it before writing the Makefile, because it's not about just going and randomly write it, right? So because it's basically gather all the information you put inside your Makefile from other parts of your project, amalgamated it, build it, and provide you the end result in a one single step. If you break down that could take thousands of steps to do the same thing. Think about the big project like Linux kernel. If someone tried to hand build every single subsystem, it might take them weeks, months to get depend on the system they're sitting on. But that's not an efficient way. That's an error-prone way too. So that is why this mechanism exists. I don't know whether you're listening to this long properly, but if you do, it will help you understand. Okay, so I'm trying to drill you through your head some basic understanding that you should put more effort to build your Makefile. It's an indispensable tool. It stood the test of time. It's still very relevant till today, and it will be. Okay, so you better learn it properly for your sake. Okay, so I'm not going to show you more example. I think I have given you enough commentary about it and shown you enough things to give you some sort of inclination. If you have real inclination, you can dabble and you can go through it. There is a online tutorial too. If you want, you can go through it. It's pretty easily available. So I'm not going to bother you to give you that kind of stuff. Okay, so I hope to show you this piece of information about such an important tool, which is Make, for building, managing project. Okay, I hope it will be useful for some people who are inclined to. Thanks for watching.